Okay, so I have this whole gnarly thing on the bottom, and it doesn't really matter what's on the top. All I need to do is figure out where this is equal to 0. In a graphing calculator, you put it into your y equals, then you just find the zeros of the function, right?
That'd be so much easier.
When you find the zeros of a function, it tells you where y equals 0, right? So type this into your calculator and see. So in the y equals screen, you're going to type it into your calculator.
Does it type 0 equals?
Yes.
Does it have to be?
Oh.
Just the bottom, just the denominator. Because remember, to find discontinuities, we're really just finding where the denominator is equal to 0. That's what we did with this easy one, right?
That makes sense. I love calculator.
So this easy one, we just said, well, where is this equal to 0? And we knew that. This one, we typed the whole, it doesn't matter. It could be anything on top. But when we're finding discontinuities, we're looking at where this is equal to 0.
The y. 0.
So then you just calculate, like you graph it, and then you calculate the zeros. And I made this one up out of my head, so their zeros might be in lots of weird places.
I don't think there is one.
There is.
X equals 0 and y equals 2.
Okay, well then my graph is goofy.
Or is it when y equals 0?
Never mind.
When we're talking about when y equals 0.
Oh
Let's
man, that's
do
harder to
the
find.
zeros.
Yep, so you would calculate zeros, and then you have to go and find like the bounds, right? We have to like
That
set
doesn't
the
work
bounds.
on these.
What does this one even look like? I just made it up.
Right bound.
Oh, okay. Oh yeah, see?
Mine is not.
There's some
The
zeros on that
zero
one.
at negative 0.1001.
Yeah, I promise that the ones on the test are not going to be so terribly made up. They actually have zeros you can find.
But we're going to have to calculate.
Yeah, on the calculator portion, there is something just like this that says, hey, here's a function that looks really crazy because it's got really crazy top and really crazy bottom. What are all of the discontinuities? Well, we know discontinuities only happen when the denominator is equal to 0. It's the only time discontinuities can happen.
Discontinuous at negative point, whatever, 1.
Yeah, so whatever these zeros are, negative point, whatever, that's where it's discontinuous, wherever this is equal to 0. It's probably going to be more than one place, right?
7, 7, 7.
Okay. So does that make sense?
Yeah.
Okay. The other thing I want to talk about is the intermediate value theorem.
This test starts tomorrow.
Hmm.
When you go with all night route.
Okay. I knew there was one.
Gives me that.
Okay.
But it doesn't put on
So
here.
you guys remember that the intermediate value theorem says that if a function is continuous, that it guarantees a value in between two other values.
Yeah, the 2 values they give you, right?
Uh-huh. So it'll say we have like f of a and f of b, and we have an interval from a to b. If it's continuous on a to b, and c
And C has to be between
is
the
between a and b, then there is a value in between f of a and f of b that equals f of c. Okay, basically, if your x value is between these two x values, then there's a y value in between the two y values of your other points. Okay. So the question is, how does this relate to zeros? If I said that this this function was continuous from -2 to +2, then I said that let me think. Yes, so from -2, there we go, that's right. If this is -2 and this is +2, and then this is like -1 and 3, do I guarantee that there's a 0 somewhere in there?
Yeah.
Why?
Because it's in between the two.
Because this right here is a 0. This, we would say this is a 0. So there has to be some number in between -2 and +2 that gives us a 0 if this was -1 and +3, right? Does that make sense? There has to be some number in between -2 and +2 that gives us a 0 for this function. So that's really why we use the intermediate value framework. We learned it, but this is like the application of it is making, like we can find out whether there are zeros or not. Yes or no? Do we want to look at it one more time?
Okay. Like do an actual problem.
Yes, I forgot to get one like prepped that wasn't the actual test question.
There's one on the review.
Is there? Perfect.
So it's x plus 5.
What number?
Number 60, I was going to see. It doesn't matter which one.
Okay.
Would it not be
Oh my
continuous
gosh.
though?
There's 68.
No, because it's one isn't included in those intervals. But it doesn't matter which one you do. I was just saying.
Okay, number 60.
Yeah, there's A, B, or C. You can use.
Okay. Perfect. Okay, determine whether the intermediate value theorem would guarantee a C value on the given interval. If it does, find the C value. If it does not apply, write a sentence explaining why. Okay. Let me see. So we will do that one, but what I want to apply it to zeros.
Or are they confused?
So instead of saying it would guarantee a C value, let's see if there's a 0 in there. Okay, so we're just trying to figure out, does it cross the x-axis or not? Okay, so the first function is x squared minus 4x minus 8 on the interval -4 to -1. And we want to see, does it guarantee that there is a C value that gives us 4? Well, first we have to decide whether f of A and f of C is in between f of A and f of B. Right? Well, actually, first we have to decide, is it continuous? Is it continuous?
Yes.
Okay, so we're good. All right. So then let's see, what's f of A? We put A into here, which would -4 into here. We get 16 minus 16, no, 16 plus 16 minus 8.
24.
Yeah, 24.
Okay, so that equals 24. And f of B, 1,
-3.
yes. Okay, so the question is f of C in between 24 and -3?
Yeah.
Yes. Okay, so that's our next condition. F of C is in between f of B and f of A.
So if it wasn't, you would just stop.
You would just stop there because it doesn't guarantee anything at that point. And then we can make our conclusions. We can make our conclusions, which says, since this is continuous, since f of C is in between f of A and f of B, there is a value in between -4 and -1 that gives us 4. So, in this question, we would say yes, and then it says, find the value. So we would set that equal to 4. And then we would just find what our C value has to be. So we would
math.
That wouldn't
Wouldn't
work.
it be minus 12?
Yeah,
Thank you.
that's what it was.
Yeah, like, in my brain, I subtracted the 4. Okay, that would make more sense.
It's like 22.
So we gotta factor it.
X minus 6 equals 2.
So our two factors would be x equals 6 and x equals -2. Those two factors, those are our two c values that would possibly give us 4.
Or 6 plus.
But which one is our c, actual c value?
-2.
-2, because it happens to be in between -4 and -1. So our c value, c equals this. So when I'm saying, are there zeros, basically all I'm saying is instead of having f of c equals 6, or f c equals 4, all I'd say is, when I say, hey, are there zeros in between this one and this one? All I'm saying is there a c that f of c equals 4? Does that make sense?
Guess and check.
Can I steal some of your students really fast? Yeah, Bryn. I can't see if you have bangs or not. So, Nate, and anxiety.
That's like the whole class almost.
Everybody dressed up.
That's lame.
Are those chocolates, Carter?
Yeah.
All right.